Hello everyone. So we are going to start with a warm-up question. I want you to pause the video, go to the warm-up section of your binder. If you've been in class with me, you got warm-up sheets. If you haven't yet been in class with me, just do it on a sheet of lined paper. You can probably get like maybe 3 days worth of warm-ups on a single sheet. No need to use a separate sheet for each day. So pause the video, go solve, and then check back in a minute. Okay, so let's take a look at our solution here. So we're going to want to start by expanding this out first. All right, so we know x minus 3 squared is really x minus 3 times itself. So we have 2x squared minus 12x plus 17 equals, now let's multiply this out, x squared minus 3x minus another 3x, so minus 6x plus 9. All right, now we want to get, since this is a quadratic equation, we want to get set equal to 0. So I'm going to take all the terms from the right side and bring them over to the left side. So I'm going to subtract x squared from both sides, add 6x, and subtract 9. Okay, so the right side just becomes 0. So we have x squared minus 6x, and then plus 8 equals 0. Okay, so now we can try to factor this. There's no GCF. We have a trinomial, so we can do use ax squared plus bx plus c. All right, so we want to look at factors of 8, which are 8 and 1, as well as 4 and 2, that we can make a 6 from, which of course are going to be the 4 and 2. So we want our factors to add to negative 6 and multiply to positive 8. All right, the way we can do that, we can make the 4 and 2 negative, so that's going to be x minus 4 times x minus 2 equals 0. And then to get our solutions, we'll use the zero product property, which says take each factor and set it equal to 0. So we solve our little equations here. So x is positive 4 and x is positive 2. Okay, let's move on to today's lesson. Okay, the first thing we want to do is review simplifying radicals. The reason we're jumping around a little bit is when we work with the quadratic formula, or a little later, quadratic formula has square roots in it, so we need to be able to simplify square roots. Radicals and square roots mean the same thing, although we do have cube roots, fourth roots, which you saw a little bit of last year. Okay, so a little reminder of radicals. So we've looked at some perfect squares. So perfect squares go like square root of 1 is 1, square root 4 is 2, square root 9 is 3, skip ahead, square root of 100 is 10, right? So these are our perfect squares because they're nice, clean, whole number square roots. If you put square root of 27 into your calculator, you would get a messy decimal, right? So what we want to do is we want to simplify square root of 27 in terms of perfect squares. In order to do so, we want to make a factor tree for 27, just simple list of factors, right? So we have 27 times 1. It's not divisible by 2, but it is divisible by 3, 9 times 3, and that's it. Okay, we want to look for a perfect square. So the only perfect square on this list of factors of 27 is the 9. So the pair we're going to use is the 9 and 3. So we're going to say square root of 27 is equal to the square root of 9 times the square root of 3, because 9 times 3 is 27. But the square root of 9 is really 3. So we're going to say this is 3 times the square root of 3, which we can just write like that. And that's your simplified form of square root of 27. Okay, square root of 600, it would take quite a long time. 600 times 1, 300 times 2, 200 times 3, 100 times 6, and oops, I forgot 120 times 5. All right, as soon as you see a perfect square on this list, stop. You don't want to keep going, all right? So I'm going to say square root of 600 is equal to the square root of 100 times the square root of 6. But we know the square root of 100 is 10. Square root of 6 we can't do anything with because it's not a perfect square. So this is going to simplify to 10 times the square root of 6. Square root of 32. 32 times 1, 16 times 2, 8 times 4. Okay. And then, yeah, that's it for 32. Okay. We have two perfect squares here. We have 16 and 4 on this list. We want to always use the largest one. So I'm going to go with this pair of 16 and 2. So I'm going to say square root of 32 is equal to square root of 16 times the square root of 2. And we know square root of 16 is 4. We'll keep the square root of 2. All right, one more, square root of 50. So we've got 50 times 1, and we have 25 times 2, and we have 10 times 5. Okay. So, the only perfect square we have on this list is the 25, so we're going to use that pair. So we'll say square root of 50 is equal to the square root of 25 times the square root of 2, which is equal to 5 times the square root of 2. Okay. So next thing we want to look at is simplifying a radical with a negative radicand. All radicand means is the inside, okay? The number inside of the square root, fancy word called the radicand. So if you look at the square root of negative 9, this is going to be a special case. So square root of negative 9, common mistake, people say it's negative 3, right? Seems quick. But here's why it's not. In order for that to be true, negative 3 times negative 3 must be equal to 9, which of course it isn't. Okay? So what we do, there's actually no real solution to this. So what we use is called an imaginary number. Okay? So our imaginary number is called I. I is equal to the square root of negative 1, right? Because negative 1 doesn't have a real square root. Because 1 squared is positive 1, negative 1 squared is also positive 1. Okay? So we're going to use this trick. We're going to say square root of negative 9 is equal to the square root of positive 9 times the square root of negative 1. Okay? So the square root of 9, of course, is just 3. And we define square root of negative 1 as I. So your answer to this is 3i. Okay. Number 6 we're going to approach this like it was square root of positive 8, but we're also going to have to account for that negative. So I'm going to take a look at the factors of 8, 8 times 1, 4 and 2, and that's it. All right, so the pair we would need is the 4 and 2. So I'm going to say square root of negative 8 is equal to square root of 4, square root of 2, square root negative 1. Okay, so square root of 4 is 2. Square root of 2 I can't do anything with. And square root of negative 1 is equal to I. And the I, anything not inside the square root, is going to come to the front. So that's going to be 2I times the square root of 2. Number 7, square root of negative 72. So again, we'll approach it like it was the square root of positive 72, but we're going to have to add in that square root of negative 1 to account for the negative inside the radical, the radicand. So 72 times 1, 36 times 2, okay, and we can stop right there because the 36 is going to be our largest perfect square. So we're going to say square root of negative 72 is equal to the square root of 36, square root of 2, and the square root of negative 1. So square root of 36 is 6, square root of 2, and then, of course, the square root of negative 1 is I, and the I is going to jump to the front. So we're going to write this answer as 6I times the square root of 2. Last one, square root of negative 12. So 12, 1, 6, 2, 4, 3. There's our perfect square, the 4. So square root of negative 12 is equal to the square root of 4 times the square root of 3 times the square root of negative 1. So that's 2 square root 3 I. And again, the I jumps to the front. 2I square root 3. Okay. So now we're going to apply square roots to solving quadratic equations. So we have the square root method, and then coming up we have the quadratic formula. So, right here. So the goal is isolate the square. All right. So in number 9, what I want to isolate is that x squared. Let me erase that. And then we're going to use the fact that the inverse of squaring is square rooting. Just like the inverse of addition is subtraction, or the inverse of multiplication is division, the inverse of squaring is square rooting. All right, so this is how this works. 2x squared plus 1 equals 49. All right, I want to isolate that x squared. So in order to do so, of course, we're going to subtract 1 from each side first. So 2x squared equals 48. We'll divide each side by 2. So x squared equals 24. And then we will take the square root of both sides. Now remember, when you're taking the square root of both sides, we need to put a plus minus sign, because the square root of 9 is equal to 3, because 3 squared is 9, and negative 3, because negative 3 squared is also positive 9. Okay. So you should remember from last year, you have to put that plus minus sign in front of the square root. So x is going to equal the plus or minus the square root of 24. So let's see if we can simplify the square root of 24. So no no negative radicand, no negative inside the square root, so we don't need I. So it's going to be 24 times 1, 12 and 2, no perfect square, 8 and 3, no perfect square, 6 and 4, there is our perfect square, the 4. So x is going to equal plus or minus square root 4, square root 6. So x is going to equal plus or minus 2 square root 6. So the way Alex wants you to put it in, it says something like separate your answers with a comma. X is going to equal 2 square root 6, that's the positive one, comma, negative 2 square root 6, that's your negative. Okay, x squared equals 45. So we already have the square isolated. We're going to take the square root of both sides and add a plus minus. So x is going to be plus or minus square root 45. Looking at the factors of 45, 45 times 1, 15 and 3, and then 9 and 5. There's your perfect square of the 9. So x equals plus or minus square root 9 square root 5. So that's going to be plus or minus 3 square root 5, which you'll write as 3 square root 5, comma, negative 3 square root 5. All right, number 11, u minus 4 squared minus 18 equals 0. So the square here that we want to isolate is this, because this is what's being squared in the blue. All right, so we'll start by adding 18 to each side. So u minus 4 squared equals 18. Now we'll take the square root of both sides. Of course, adding a plus minus in front of the 18, the square root of 18. So the square root of u minus 4 squared, again, square rooting undoes squaring. So we're just going to be left with u minus 4 equals, let's simplify that, square root of 18. 18 times 1, 9 times 2, there's our pair. Plus or minus, let's see, that's plus or minus square root 9, square root 2. So that's going to be 3 square root 2. Add 4 to both sides. So u equals 4 plus or minus 3 square root 2, which you can write as 4 plus 3 square root 2, comma, 4 minus 3 square root 2. All right, last one. X plus 1 squared minus 28 equals 0. So we're going to isolate that and start by adding 28 to each side. Okay, and now we can take the square root of both sides to undo that squaring. So x plus 1 equals plus minus square root 28. So 28, 1, 14, 2, no perfect squares. 7 and 4, yeah, we got a perfect square there, the 4. So that's going to be plus minus square root 4, square root 7, plus minus 2 square root 7. So x plus 1 equals plus or minus 2 square root 7, and subtract 1 from each side. So x equals negative 1 plus or minus 2 square root 7, which when you write it out with commas, like your assignment's going to want you to do, it's going to be negative 1 plus 2 square root 7 comma, -1 minus 2 square root 7.